Having discussed propositions, proposition variables, we shall look at couple of logical implications and equivalences which will be of use when we start simplifying an argument and to check whether so and so conclusion follows from a given premise or not. The last lecture, when we looked at a case study, subsequently when we modeled that using a logical expression, we observed that it was P implies Q and negation Q implies negation P. Now when you converted the argument, when you model the argument as a logical expression, this is precisely what we add as part of the premise, and conclusion was this: we wanted to know whether this follows from this or not. Correct? Now an expression of this type or implication of this type is what we want to discover more as part of this session. So the idea is this: if you look at this one as say x, this one as y, so you are given an implication like this. We want to know whether y follows logically from x or not. Correct? And when we looked at all possible values for p and q, we observed that x implies y was indeed true. In fact, for all possible values of p and q, the expression x imply y is evaluated to true. If you look at the column x implies y, we saw that it was true everywhere. Correct? Which means y follows from x. So now something like this is what we are going to discover. So here is a definition: a tautology. So the expression x imply y is a tautology if x imply y is evaluated to true for all truth values of propositional variables appearing in x and y. So for all possible values of truth values, so now possible truth values are true, false, like that. Now you get to see that for each of them the expression is evaluated to true, which means x implies y is a tautology. If x appears in a context, replace x with y. That's precisely what this says. So let's discover more on this. So when do you say something is contradiction? So for all possible truth assignments, if x implies y is evaluated to false for all truth values. So truth values could be true or false. For each of them you see that x implies y is evaluated to false, then it is a contradiction. If the last column is true for all of them, it is a tautology. If it is false for all of them, it's called contradiction. Okay. Let's look at a couple of expressions. So let's look at P implies Q implies negation P or Q. Can I infer this given this. Does this follow logically from this? In a context, if P implies Q appears, can I replace it with negation P or Q? That's precisely what our focus is. Let's verify. Look at PQ. Possible values are true, 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 false, false, true, false, false. P implies Q is true, false, true, true. Negation P is false, false, true, true. Negation P or Q, if one of them is true, then it is true. Yeah. Now you can see that the values over here and this is precisely same. The column, it is identical, which means this implies this. In fact, there is a stronger statement. Suppose this is X and this one is Y, then X implies Y is what? True, true, true. False is true, because they are identical. Now definition says if X implies Y is evaluated to true for all possible assignments for P and Q, then this expression is a tautology. Okay? But the column being identical, right? Which means it gives you a stronger statement, meaning negation P or Q implies this. It is not that P implies Q implies this. It also means this. Negation P or Q implies P implies Q. Let's look at that. If you look at negation P or Q implies P implies Q, let me call this one as say Y, this one as X, inconsistent with this. Now you look at Y implies X. If you look at Y implies X, we see that it is true everywhere, which means this one is a tautology. This one is also a tautology. Okay. So when do you talk about logical implications? X implies Y. Let me call this one as implies. X implies Y if X conditional or X implies Y is a tautology. The word implies is overloaded. When we say implies, you can imagine or you can assume that we use when X implies Y is a tautology. Otherwise, one has to check. Okay. Otherwise, it could be a tautology or it need not be. And we also see that Y implies X, which means Y implies X is a tautology. Now in this case, it so happens that both are true, which means they are equivalent. So if X implies Y and Y implies X, if both are tautology, then X is equivalent to Y or X biconditional Y. So this is called equivalence. So we say two expressions are equivalent when when x biconditional y is a tautology, or you see that x implies y and y implies x is true. Look at x biconditional y. If you look at x biconditional y, it is true, true, so it is true. False, false, it is true. True, true, it is true. True, true, it is true. So, if x biconditional y is true everywhere, then these two expressions are equivalent. If x implies y is a tautology, or x conditional y is tautology, then x implies y. If both are true, x implies y is a tautology and y implies x is a tautology, that is equivalent to saying x biconditional y, and they are equivalent. If it is equivalent or equivalence, then biconditional is true, or both directions are true. X implies y and y implies x. If it is logical implication, it is only one direction. X implies y alone, okay, or y implies x. If it so happens that both are there, then it becomes logical equivalence. Let's look at this expression. Negation P implies negation Q, and on the other side, let me look at Q implies P. I wish to know whether these two are equivalent or not. Let's experiment and see. So I want to know this one, are they equivalent? Which means, is this true? So question, are they equivalent? Let's look at possible values for P and Q. Possible values for P and Q are this. Negation P is false, false, true, true. Negation Q is false, true, false, true. Then we look at negation P implies negation Q. You see that this one is true, it is true. When premise is false, you can immediately write true without even looking at the conclusion. True, false is false, this one is true. Then let's look at Q implies P. Q implies P is true, premise is false, so it is true. True, false is false, premise is false, so this one is true. Now, negation P implies negation Q implies Q implies P. Implies Q implies P, or whether the biconditional is a tautology. If you look at the biconditional, this one is x, this one is y. What is x biconditional y? You see that this one is true, this one is true, this one is true, this one is true. So with this, you can conclude the following. If x biconditional y is a tautology, then x is equivalent to y. Logical equivalence. Equivalent to or logical equivalence. If x conditional y is a tautology, then it is a logical implication. X implies y. This is logical implication. Okay. Alternately, if x conditional y and y conditional x both are tautology, then x is equivalent to y, or x biconditional y is also a tautology. Fine. So there are expressions of this form which we come across when we look at logical arguments, and we wish to know, can I replace this with this, or can I replace this with this? So that's the kind of thing we wish to explore.